welcome back. Today, I need to add some new field types to a code generator. The code generator is written in Typescript, and it generates Solidity from a configuration file. The config file used for input can be either Typescript or JSON, and is basically an entity model, much like an entity or record configuration in an ORM system. I need to add a bytes 8, bytes 16, and bytes 32 type to this, so let's get started. All right, so PDK project open, and let's go figure out where we need to edit. We have everything organized into packages, so it's not going to be, the PDK package is primarily just for the command line. So let's go into common. All right, code gen sources and code gen, that makes sense. And I think the first thing we want to do is add it to our types that we use. All right. So this is Typescript, and here are all the types we currently support. So I'm going to add, bytes 8, bytes 16, and bytes 32. Thank you, Copilot. Let's see if there's anything else we need to add right here. Bytes 8, 16, 32, and a comma. Okay, so now we have some additional field types. What I like to do is I like to write tests that fail and then sort of backfill the correct behavior. Test-driven development, as some people say, right? So we have tests. I don't need to add any new tests. What I actually need is new test data. So I have all of these test configurations. And I think what we'll do, we'll go check one of these out here. This one just has a couple of bools. So I think what we'll do is we're going to copy 2 bools, and we are going to make it be the bytes. All right, so this is going to be bytes, symbol bytes, and it's not saying it validates right now because I haven't actually uploaded this new schema file yet. Oh, that is something we need to do. We need to update the schema. So let's get that done. We'll do that in 1 minute. Okay, now time to update the schema. Question is, where do we put them? Oh, there. All right. Contract config, we need to add our new types. Copilot, help us. We'll just copy this because we know we have to do the same thing into the metadata schema. And that's done. And now we can run our current code gen and go see what's going to work and what's not going to work. So first I'll build. First I'll install. Then I'll build. Then we are going to go into the test data, and we should have a bytes JSON. So we'll say PDK generate, I forgot, we changed the name of it recently. PDK generate contracts, bytes.json, Error. Invalid config file. I bet it doesn't work because the schema, the contract config schema isn't current. Did I update all of them? Let's go look. I feel like I didn't know. Yeah, okay, yeah, I updated both, right? Should be using contract config. Bytes 8, bytes 16, bytes 32. Inner bytes JSON, we had bytes 8, bytes 16, bytes 32. I would actually expect, here we'll do validate. Unknown field type, bytes 8. Oh, no, there's more I need to do. Okay, because we did that, we added it to the field type here. And then, but we also need to what else do we need to do? Why doesn't it think it's invalid? Okay, so let's go look at our validator. Here's validate schema. And so the error message we got was unknown field type. And that's not coming from this file. But I know it's coming from validate contract config. And validate contract config is going to call this contract schema pull validate. And oh, here we go. There's another mapping here. Okay, so let's just go ahead and we'll do bytes 8 and see if we get some help here. And we do. That's right, because we have to actually define the number of bits in it, effectively the data length. Okay, now we have it everywhere. We have it in our schema JSON. We have it in our our type TS file. We have it in our validator. And I'm just looking and thinking for a minute. Is that right? Yeah. Okay, yeah, that looks good to me. All right, now I should be able to rebuild. Yeah, we're gonna do this a little differently now. Okay. So we're gonna build. Now we're gonna say PDK generate contracts. Test data slash bytes, and let's put the output in test data. And there we have it. Now these aren't going to be right though. So the next thing that I like to do is go edit those files that were just generated. So we want to go to the generated one. And so we do have 3 actual types in the metadata. And now we're in Solidity, and so we actually have to go to the core contracts for Patchwork and add these types in. And now let's see. Should be in iPatchwork 721 right here. So we can change this enum, I think, without consequence. Yep, I think that's good. Okay, so now in order to let this build in Solidity, we need this to be committed. Yeah, we need to, we're going to need to push a new version of this. Is basically a submodule it uses. So we have to push this. And I'm thinking of anything I need to think about here before I do it. we don't necessarily need test coverage on this here because we're going to do it over in the PDK side. So this is just core. Okay, but I actually am going to add, just being a little bit verbose, you know, I'm not really used to broadcasting or streaming or recording when I do these things, and so my brain's trying to do two things at once. It doesn't work great. Okay, so yeah, this is correct, right? Because it's 8 bytes long and each byte's 8 bits, so it would be 64, 128, and 256. That's exactly what we want. This does not affect any function signatures in the on the interface, therefore it does not affect the ERC165 call to see if this implements interface, so we are good. All right, so I'm going to now drop back and go up. All right, let's see what's going on here. So we've got this change. Okay, so in order to do this, we need to, well, first let's test. Let's make sure everything's working and that we didn't break anything. And I think this is going to become V205. All right, test pass. Let's edit our package JSON and let's change this to version 205 of the core contracts. All right, take a look in here again, make sure everything looks fine. Okay. Let's add our files. Let's commit bytes types to Patchwork 721. Oh, I did not make a branch first. Good job, me. Okay, let's push this branch up. Back on main, I want to reset my main to the latest head, latest origin main. So I'm going to go get reset hard origin main. And now I pull the merged main. I merge my V205 branch in. And there it is. And now I need to tag it, 205. Now we need to go back to PDK. And we need to update our lib patchwork to be, let's see, we'll check out V205. Oh, gotta pull all the tags. Check out V205. Okay, so it's on V205 now. And then I also should edit the submodule config so that it says it's on V205, but okay. I guess that's not how we did it, so I'm not gonna worry about that. All right, now if I do let's see, if I do a forge test, this is the bytes generated is failing right now, and I would expect that. That's okay. Cool, so let's go ahead, let's get back into VS Code now, and we'll get off of the Patchwork project, and instead we'll go over here. And now we should have these field types. Now we actually need to handwrite the right code, and then we will get our generators fixed. So let's see, if we're packing metadata into slots, so the slots are 256 bits. This is correct. It knows. So what the code gen already knows is it already knows the width, the size of each of the fields. And so it generally understands how to lay them out, but it does not know how to specifically convert in Solidity. That's just not added yet. So if I remember correctly, so this is a byte 16, And a byte 16 first it can go directly to a uint 128 before you cast it to uint 56. And the same with this would have to go to uint 64 like this. Okay, and let's make sure. Okay, yeah, bytes, yeah. Let's see, B1 is bytes 8. B2 is byte 16. Okay, so this will actually work now if we can get it to generate that code next, which we're going to. Okay, then the opposite needs to be true. So you can go directly from a uint, each slot's uint 56, so you can go directly to a bytes 32, but here we first have to go to a uint 128, and then here we have to go to uint 64. Whoops, no, uint 64, I was just thinking about the shift and when that needs to happen. And I believe we need to shift it before, yeah, we obviously have to shift it first. Because this is still a 256-bit, so it would shift it. You have to imagine it's going to, you're going to push off all the zeros off the edge so that the value you want's left on the very least significant. Okay, if we want to think about Indianness, but I think about it on the right. So the value is on the right, so that when we actually truncate the value, because that's effectively what you're doing is you're truncating the value. If you're casting from what is a 256-bit number down to a 64-bit number, you have to lose 192 bits somewhere. And so what we want to do is shift it over and then truncate the rest so that we have only the part we want left right there. So we'll shift it over while it's still wide, because if we truncate it first, we're going to have the part we don't want, and then shifting it isn't even going to make sense. So this is correct for pack and unpack. And then we have to just go through and do all the same stuff here. So here, so for loading this, we would need to, again, do 128-bit. And we're storing. I have to think through a little bit of this while we're doing it. Yep. So we're going to go, okay, because we're going from a byte 16 to a uint 128, and then from the uint 128, we're just going to add on prepend. Basically, you're thinking about it prepending a bunch of zeros, so 128 bits of zeros, and then we're going to mask it off. It's fine. Okay. Same deal. This needs to be cast to uint 64. And then over here, again, uint 64. Okay, so we've updated our code. So now we have the code we expect that it will generate. So if I run forge test, let's see, where are we? Common, packages common. So forge test, I expect to pass. We don't have any tests written for this right now. And it has to recompile everything because I changed an interface that nearly every file uses. Okay, all the tests pass. And now, if I run pnpm test, this is going to run all of our tests we wrote in TypeScript, which are going to compare what's being generated to what we're expecting to be generated. So now I expect this to fail because we've changed the generated code to the right code, but the generators themselves are no longer right. All right, so we have a number of little things to fix here. So we've got pack and unpack metadata functions to fix. So I'm going to do those first. And then we've got the field level functions. So our generators, I happen to know, were organized into, let's go see here. We're organized into the pack function generators and the field function generators. So all I have to do is touch these two. So I'm going to have to take a minute to look at this and think about it and read through. So this does the pack function. This goes through the storage layout, goes through each field of the storage layout, and it doesn't do dynamic arrays of any kind. It skips those. Okay, so I think all we need to do is add a bytes something to do bytes. Okay, and now this is still going to do the wrong thing, but if I go back and I look at the code we need it to be, we had to add, all we had to do on the pack and the unpack was add the cast to the uint of the actual width on here. So what's conversion? Let's go look at this really quick. Conversion is data field key. Okay, so this must be, this is just the pack function. Okay, so the pack function by default is just going to do uint 256 and then that. So what we need it to do actually is we need to make conversion. Actually, I can so I can say conversion is, and then we can wrap this in uint, but then I can say, yep, element bits. And yeah, that'll actually work right there. And then wrap it in a 256. And I don't mind this being 2 lines of code because at least I can think it through just a little bit. Okay, so that's the pack function. Let's rerun our test and see if we fixed it. Expecting failures, sure. But let's see. Okay, so this is now saying that we expected oh, those are right. Oh, interesting. Okay. Did I not? Okay, what? Okay, let me read this code for a second. This doesn't feel right. Feels like, oh, index. Okay, this is a funny way to do this. It feels like a very indirect way to check for the presence of an item. So we're saying the index of the field type. Okay, because this will return -1. So, okay, that's fine. So it should be, so what's interesting to me is our bytes 32 isn't working. I'm not sure why yet. It looks like the other two work. The bytes 8 and the byte 16. Oh, it's because the bytes 32 doesn't need to be converted. It already is a uint 256. Of course. Okay. All right. So now we need to do unpack. Yeah, I forgot. We can go directly from bytes 32 to uint 256. So, okay, so let's go look at unpack and see if we need to do the exact same thing. All right, I'm going to copy this same bit of code to get started, and then we'll do the reverse equivalent. Okay, so what we're going to do is we are going to grab this, and we're going to unpack lines equals, I think we need to go, uint element bits like this, and then on the slot shift, like that. We don't have element bits, but we do have field.element bits. Okay. Taking a look again at what we need for unpack. Yeah, we got the shift inside. Everything's inside. Okay, let's try this. All right, unpack works. So now we need to go to the field generators. I'm going to leave this open just so I have it as a reference in case I need it. Now, what's funny about our code gen, it doesn't model or you know, tokenize or other, like model the structure in any way that the code is. It is just procedural. It just runs through field by field and just generates the individual lines of code that we know are required to make things work. So one thing that's nice about that is that it's fast to work on, because I can just grab this and I can just put this right here. What am I in right now anyway? I don't even know what I'm doing. Oh, this is for, okay, wait. So we're in a field and this is for an array of these. So we have to separately support the array from the non-array. So we should actually add a test case for arrays when we're done with this. Let's see. I'm just gonna let this, oof. Okay. So I'm going to add a very similar thing. This is almost identical. This is identical. This is, I just realized something. I think we might just be able to case this with the ints. I think it'll do the same thing. I think we can literally go put the bytes along with the ints. Why did I not see this before? Hold on a minute. The pack function. Is this the, did I just literally make the exact same? I did. I mean the exact same code. Okay, that's dumb. Here's what we're gonna do. We're just gonna treat them the same as converting ints to uints. Just like that. Okay. Can I do that up here too? Ints. Yeah, if I had formatted this the same, I would have realized this earlier. But yeah, that's funny. Well, I'm glad I caught it now, because otherwise I would have committed that and then it would have just created more confusion later. Okay. You know, let's just go all the way with this. Let's go find all of the int conversions because they're complete. And we will just append our 2 bytes types that needs to go to this and just see if that just works everywhere now. Because it might. Just might. Oops. Okay. And I'm just looking, I'm manually looking through code instead of searching. Because I'm also sort of scanning for anything else that I might be missing right now. Okay. We should have had 4 total changes. 1, 2, 3. I see 3. Okay. So this is, let me go see this. Generating load and store functions. So this is if it's an array, and then if it's not, and then we have a separate, yeah, load and, okay, so there's 3. There's 1 for arrays. It doesn't quite feel right to me. It feels like there should either be 2 or 4, but there's 3. Okay, so let's go ahead and see if it generates the right code. It does. Very cool. Okay, so we now just need to add tests for arrays. So what I'm gonna do is go here and I'm gonna add an array of bytes 16s onto this. This will be field number 4, and we are going to, oops, do array length, and we'll just do, let's see, because if we're doing 16s, let's just do, let's make them 8s. We'll do bytes 8s, and then we can do an array of length 4, and it will it will then take up a whole slot. Okay, so now we need to actually rebuild PDK. So dropping back, building. And I'm going to run that same command. And we're going to regenerate the bytes contract. And now if we go look at that bytes generated contract again, we should see a fourth field. And this is looking pretty promising. We've got the load and the store for those. And let's do a forge. Oops. Oh yeah, it does work there. All right, let's do forge test and packages comment. Should be the same thing, and it is. All right, and the last thing that I should do is generate a test for the bytes generated so that we can assert that everything being put in is the same thing, or everything being read is the same thing being written. But I would like to use some AI to make that test. So I think I'm going to do that. I think I'm going to do that separately off camera for a minute because I haven't used this stuff in a little while and I need to craft a little prompt for it to do this. So, all right, so it made this right here. Well, I think it knows enough. Okay, it's testing the schema. It's testing all the load. Let's go testing load and store for B1, B2, and B3. It's testing pack and unpack, so it knows. Yeah. Oh, this looks actually pretty good. Okay, well, let's do a forge test and see if it worked. And obviously there's no mint function, so the call to mint isn't going to work. So what do we need to do here so we can mint? Let's go take a look at one of our other tests and see if we can just patch this up. We'll look at 2 ints. Okay. All right, so we made our own. Here's the part I missed. We're going to add a contract called my bytes. His bytes, and we'll just add a mint function, and now we can mint it. And now all we need to do is change it so that instead of the contract being a bytes, it'll be a my bytes. Oops. There we go. See if that works. And let's see, in our mint function, does not need any data, so oops. Okay, now it's saying bytes.metadata doesn't exist. So let's change this to my bytes. See if that works. I'm really not thinking hard about what I'm doing here, so this might not be the way to go. Metadata is not found. Okay, hold on a minute. Let's go back. All right, it should be, because it's in bytes generated. Oh, does it need to be bytes generated at metadata? Probably. All right, okay, so let's find the mint calls. And we'll just change them all to need no second arguments. And now we're down to right here. Field type is not found or not visible. Okay. Oh. Yeah, because it shouldn't be bytes.field type. It should be, let's look at a different test here and see. Patchwork metadata, that's what I thought. Okay. And then member name, limit entries.name. Do we have name? I think it, oh, it's, I think I guessed it was called name, but I think it's called key. Again, we can look at another test here and see, yeah, it's key. There's actually more I would like it to test here, and so maybe I'll manually, yeah, okay. Okay. Yeah, we wrote this, before it was called array length, it was called field count. Okay, we've got some failures now. Test base URI did not work. See, this is why it would have been really nice if it had, oh, see, it tried to hard code, it's trying to hard code a token ID here, and that's not going to work. We're going to need to mint that, so yeah, it's annoying. All right, and also it's not using the, okay, let's fix this. This is some made up AI nonsense, is what this is. Let's see, wait, schema URI. Yeah, that's fine. Okay. That's fine. This should be using token ID now. Okay. And then we're going to get more failures. ERC721 invalid receiver on test base URI. Okay, so it's because owner is set to the address of this. Yeah, let's not do that. Let's not do that. Let's have it so it, oh man, I wish we'd just copied this. This is really annoying. I don't think we need all this necessarily, but here, let's just make, I just want to get this working, so we'll see. This is a poorly generated test. All right, yeah, this is not going to work the way we want either. Can't have multiple. Let's go see how the actual image URI function works on here, because I think the answer is actually right here. Yeah. Ah, strings.toString. Okay, that's why. All right. So we effectively need to copy this and this. Oops. Okay, it's forcing me to wrap this. That's fun. Okay. All right. Okay, now we're getting not authorized. So where's this coming from? Test load and store B1. Test load and store B1. So, aha, it's saying we can't store values because we did not create this contract. Again, missing the structure. So what I like to do is I like to say there's a scope owner like this. Okay, so basically let's replace owner with user. So we're gonna say we're gonna get rid of owner and instead we're gonna have it be user. And let's replace all these. Okay. Then let's see. I'm gonna copy some of this. Let's have bytes contract, and let's rename this to underscore bytes contract. Okay. And then let's see, we had user. Yeah, let's just be consistent here. We'll rename this to user to user address, just so it matches. Oops, okay, for some reason I got this. I didn't see how that happened because I was too busy typing. Oh. Oh, yeah, because this should be owner right here. It should be manager and owner. These got changed where I do not want them changed. That's fine. Okay. All right, and then this one, this should be manager. All right, so some megabytes contract, and then, all right, that's better. And then, yeah, it's got doubled up again. Okay, so we've got a user address, we've got a manager, and what I want is a scope owner. So let's just grab this. It does not need to be public. There's no reason any of these are public. Okay. And let's set the scope owner to random address. It's funny, on this one we actually deployed Patchwork protocol to make the test. Over here it's really not necessary, so it doesn't matter. Just make it something different. Okay, and then I'm guessing, yeah, we deployed it, so we deployed it as scope owner, and that makes it so that when we are taking actions that require scope owner permissions, that all we have to do is wrap them in this, such as these store functions. So like right here we want to switch over to scope owner, store that, and it doesn't matter if we're not scope owner to load it. So we'll just do that. So anywhere we see a store, pack doesn't require anything. Go like this. Yep. I'm guessing I broke some stuff. Okay, line 36. User address. Why are we testing our user address? No, we don't need to test the constructor. That's superfluous. Not authorized again. Okay, why not? Why not? Oh, it's because the owner became a user address. So yeah, let's not do that. There we go. All right, more interesting stuff now. Array out of bounds access on all of it. Interesting. Okay. Is it the problem in the test, or is it a problem with... I think I know why. I think my mint function, yes, we didn't create. Okay, so we're manually creating storage here, and I think we need 3, not 1 slots, so I changed it to 3. Still out of bounds. Okay. What's out of bounds? So all of them, all the stores are out of bounds. Got those 2 going to slot. There should be 3 slots. All right, let's go look at the generated code again and go see. It should describe itself. Oh, 4. Oh no, sorry, 4 fields. I see 2 slots. Or sorry, I see 3 slots total, 0, 1, and 2. Oh, pack metadata goes all the way to, oh no, that's an array. Okay, what am I thinking here? Yeah, slots 0, 1, and 2. Oh, nope, slots 0, 1, and 2. Okay, I feel like something's just wrong here with the generated code again. Because it grabs the next token ID, it mints it, and then it creates an array of storage for it. Okay, so let's go one at a time here to debug. So store B1. Oh, you can't just do that. You can't just say token. Okay, that's the problem. We don't know the token ID. Can't just make that up. All right, let's change all of these to actually do the right thing. More LLM nonsense. I would have saved a lot of time specifically telling it to copy another test that I knew worked. There we go. Okay, all the tests pass. All right, so now that we have passing tests, let's add the test for bytes field. And I suppose I should look at the actual values it's using. It's making sure 1, 2, 3, 4, 5, 6, 7 all work. Yeah, no, it's fine. Okay. And then before we finish, we should make sure the whole thing tests out. Oh, okay. I know what's going on. This is just making sure JSON looks like the right JSON. So what it's doing is it's generating JSON as an output, and it's trying to compare it to this, and it's just the fields are in the wrong order. It doesn't like that. There we go. Everything passes. Okay, we just successfully added some field types. So if you want to talk to me about code generation, go ahead and leave me some comments, or meet us on Discord and we can talk about this. So hope this was useful, and we'll see you all around.